Hey everybody. Today's lesson is on Metamorphic Rocks with an emphasis on this reference chart called Scheme for Metamorphic Rock Identification. So what I want to first point out is there's actually two ways metamorphic rocks can form, and that's in this column of the chart right here, okay, where it says type of metamorphism. So there's either what's called regional or contact. And just by looking here, it tells you the difference. So regional, if you look here, it involves heat and pressure, while contact is solely heat. All right. Now, you can also have two types of texture. So on the very left side of the chart, where it says texture, okay, you can have either this term right here, foliated, or non-foliated. Okay, so what we're going to do is break down this chart really into, even though there's two types of metamorphism, we're really going to break it down into whether the metamorphic rock is foliated or non-foliated and what that means and how that could possibly form. All right. So let's just go over some basic notes. And you have this Google slideshow attached in your Google Classroom as well. So hopefully you bring it up and you look along as I narrate. All right, so the definition of a metamorphic rock is a rock that forms when an existing rock is put under extreme heat and or pressure. So metamorphic rocks come from other rocks, all right? And the process that forms the metamorphic rock, we call it recrystallization. So let's break that word down. Means like a do-over, like a rerun, a redo. And then crystallization means the act of becoming a crystal. So rocks already have crystals in them. So if you put a rock under extreme heat and pressure, the crystals are forced to change. We call this process recrystallization. So it says right here, a process in which rocks undergo change without true melting. So it's very hot and there's a lot of pressure, but not enough to turn the rock back into magma. But it's enough heat and enough pressure to change that rock into something new. Now, the analogy I gave when we were doing the rock cycle lesson, I liked to think of a metamorphic rock as a burnt rock. Like if I had a really bad burn on my shoulder here and you saw it, you would know it was a burn, or you would know something changed the skin because it would look different from the surrounding skin. Now the skin wouldn't melt, but the burn would change the structure of the skin. So it's now something different than it was before. And that's what's going on with recrystallization. So that's the process, and the group of rocks is called metamorphic rocks. And the types of metamorphism I just mentioned, there's two types. Regional, well, there's the word region, which means this occurs over a large area and it has intense heat and pressure. These are the kind of rocks that can form what's called foliation. And foliation is when minerals align due to pressure. So it would look like the rock has stripes or bands, like alternating, like the rock was literally wrapped with different color rubber bands. And we actually call that banding. Regional metamorphism is usually associated with mountains and convergent boundaries because you need a tremendous amount of pressure to form a regional metamorphic rock. The other type of metamorphism is called contact metamorphism. And this is the changing of existing rock through contact with magma or lava. So basically, this, since it says contact, means the rock was just touched by lava or magma. So if a volcano erupts, that lava has to spill onto existing rocks. When it does that, it's going to burn the rocks it touched. So that means touched, it means it came into contact. Right? So we would call that a contact metamorphic rock. And it's only by heat. Right? And these can never be foliated. Sorry. All these things are coming up as once. Rocks are non-foliated. So since there's no pressure and only heat, you can't get these minerals lining up in layers. Okay, so minerals are not aligned. All right, so what I did just now is the first chart that I put up on the slideshow. I only gave you this is just the top half of that chart. So these are all, if you look here, regionally forming metamorphic rocks. So these are all foliated. Now, if you look, there's two types of foliation. There's mineral alignment. So basically, it means the minerals aligned in layers. But this is very small. It's hard to tell. See, the minerals are fine to medium. Or there's, what it says down here, is banding. And banding, it's really easy to see the foliation. The foliation is quite large, medium to coarse. Okay. So if you took a rock and you put it under a little bit of pressure, low grade, that rock could turn into slate. Then if you take it and you put it under more pressure, see here, it says regional, and then the arrow goes down. That means the pressure and heat are increasing. So if you take slate and put it under more heat and pressure, it could turn into phyllite. If you take phyllite and put it under more heat and pressure, it could turn into schist. And then the highest pressure rock is called gneiss. And they say that right here, high grade metamorphism, medium to coarse. Okay, so now I'm going to show you what these rocks look like. And just like all these other units with the rocks, we would typically have a lab. So you would get these rocks like hand specimens. So you would actually get this rock. So this rock is slate. Now, slate looks very similar to shale, but it will never have any fossils because the heat and pressure would destroy it. See, it says low-grade metamorphism of shale. Okay? And you might have heard of slate. Maybe you heard of the saying, let's start with a clean slate. So hopefully next year, you guys go to high school, you'll all start with a clean slate. Where'd that saying come from? Well, there's this old medium that teachers used to use before the whiteboards, before the smart boards. They used chalkboards. And guess what the chalkboards were made out of? That's right, slate. And sometimes the kids would even write on their slate tablet. So instead of having an electric tablet, they would literally have a piece of slate and a piece of chalk and write notes. So the next day, guess what they would do? They would erase the notes, therefore starting with a clean slate. Okay, so there's a little history with some terminology in your language, in our language. All right, so the slate, if it gets put under more pressure, could turn into phyllite. Phyllite, if you look at the comments, foliation surfaces are shiny, so it's a nice shiny rock. And if phyllite gets put under more pressure, it turns into a nice piece of schist. And the schist in New York State sometimes has a lot of garnet crystals. So that little red, bright, dark red spots is garnet. Okay. Most of the rock in Manhattan, in Central Park. So if you ever go picnicking in Central Park, and there's those exposed huge boulders, They're all, it's actually called Manhattan schist. Okay. And if that rock gets put under even more pressure, it could turn into gneiss. And there's some gneiss in northern Manhattan and in the Bronx. Maybe some of that rock exposed in the Bronx Zoo are both these kinds. Okay. So I like this image here. So it's really the same thing. It's showing you that shale right here will turn into slate, and then more pressure turns into phyllite. Phyllite turns into schist, and schist turns into gneiss. Let me actually go back one page. Sorry. Okay. This was the only one right here that has what's called the banding. See how this looks like it has alternating colors? That's due to intense pressure. So the minerals align in layers that are very visible, and we call that banding. See, you have layering here, but it's so fine or thin that it's hard to tell. So that's what we call mineral alignment. They're both foliation, just one's fine and the other's coarse. Okay. So this is showing you how the grades of metamorphism increase. So slate would be the lowest pressure, and then as I go down towards the lower right, gneiss would have the highest pressure. So if I took this rock right here, see the quartz and the clear right here, see the quartz, the feldspar, the amphiboles. So this is a granite, or actually this is diorite maybe. If this gets put under tremendous pressure, the black and the white and the grays will all get flattened out, and it will look like they're lined up in layers and will turn into this rock. So let's actually show you that. Okay. So you take a rock with random spread out minerals, which was igneous. You bury it under extreme heat and pressure, and it doesn't melt, but the minerals and the rock gets changed forever, and now it's aligned in layers. Okay, and this kind of foliation is called banding. All right, here's some exposed rock in Central Park. So you might have been there before and walked on it and picnicked on it. So this is Manhattan schist. Very common. And it's one of the reasons why it's extremely hard rock. And it's it gave Manhattan the foundation to build very tall skyscrapers. So if you look at Manhattan's skyline, it goes from like you see an area with really tall buildings, then it gets low, then it gets high again. There's like a valley of low buildings between two areas of really high buildings. Where the high buildings are, you have extremely hard metamorphic rocks, and the skyscrapers are rooted into that hard bedrock. And where the low-lying buildings are, that's sediments. It's just fill. It's sediments that fill the valley. So the rock that made up the land wasn't hard enough to root skyscrapers. So that's why the Manhattan skyline actually looks like it does. It has to do with the rocks that make up the land. There's gneiss in the Bronx. This is right by Van Cortlandt Park in the northern Bronx. Most of you know that I coach cross country. So that's one of the best cross country courses in the country. So some of you, if you run in high school, you'll run there, Van Cortlandt Park. All right, non-foliated rocks are exactly what they say. So they don't have any layers, therefore non-foliated. So most of these form just by contact, see? But you can also have regional, but I guess the pressure isn't enough to make it foliated. Or you can have regional or contact. Now what you really want to look here is this would be the column that says comments. So if I took a rock like sandstone, see my cursor's on sandstone? So if I took sandstone, which is a sedimentary rock, and put it under heat and pressure, it would turn into a rock called quartzite. If I took another sedimentary rock named limestone or dolostone and put it under tremendous heat and pressure, you would get marble. Okay? If I took conglomerate and put it under heat and pressure, I would get metaconglomerate. See, this comment says pebbles. All right, that means this was a conglomerate. All right. If I took normal coal, sedimentary coal called bituminous coal, and put it under heat and pressure, it becomes a harder and denser coal called anthracite. Then you would look in this column right here for the actual minerals. So if I ever asked you what mineral is in marble, you look right here and you would see calcite. What mineral is in quartzite? Well, the name gives it away. You look right here, quartz. All right. And that's how you use this chart. So since these are non-foliated, these can look very similar to igneous rocks or chemically formed sedimentary rocks. They can be quite crystalline, like marble, and quartzite look like crystals. Nope, sorry. So let's take a look at some of them. Oh, here we go. So sandstone, put it under heat and pressure, turns into quartzite. And then if I take limestone and put it under heat and pressure, turns into marble. Okay, so one thing that isn't on the charts that you need to know is that metamorphic rocks are always harder and denser than the rock they came from. And we call the rock they came from the parent rock. So limestone would be the parent rock for marble. Therefore, marble is the daughter rock. So just like earlier over here, sandstone is the parent rock. So sandstone kind of gave birth to quartzite. Quartzite is the daughter rock. The metamorphic rocks are harder and denser, and that's because of the pressure. All right, so the daughter rock is harder and denser than the parent rock. All right, that's it for today's lesson. Okay, as always, ask me at the Google Meets if you have any questions. All right, and subscribe to my page.